Welcome to the deep dive. Today, we're looking into something pretty huge, a framework claiming to be, well, a genuinely unified theory.
Yeah, it's ambitious stuff.
Our source material basically argues that the way subatomic particles, interact, that structural logic, it's the very same logic that shapes human societies and even determines things like prosperity and poverty.
It's a bold connection, definitely.
Yeah.
We're diving into what the sources call the universal law of increasing complexity, ULIC for short. The idea is that everything is built on this kind of continuous cascade.
Right.
And to see if this holds water, we're starting where things are really precise, really measurable physics. Because if these fundamental forces, interaction, balance, relation, if they work the same way at the quantum level, then the argument that they also shape, say, economies or governments, well, starts to look a lot more solid.
And the really provocative question here, the one we kind of need to keep in mind throughout this is, does just witnessing something change what happens?
The sources are very direct about this.
They really are. They state flat out, observing is participation, which, if true, takes awareness from being this passive internal thing
Might just interact.
to being an active structural force out there in the universe. It's a massive claim.
It absolutely is. And to back it up, the sources start by laying down the fundamental rules for how complexity even emerges. They call it the cascade architecture of complexity.
Okay, the cascade architecture.
Yeah. The model basically says physics leads to chemistry, chemistry to biology, biology to social organization, but not as separate boxes. It's continuous. Each new layer inherits the laws from the layer below it.
But then transforms them somehow?
Exactly. Transforms them into new, kind of higher level ways of organizing things.
Yeah.
New expressions of order.
So complexity is always building, always changing. What's actually driving that? What's the engine here?
Tension. That's the key driver. Specifically, the tension within existing structures. Think of it like a push and pull between being open, flexible, and being constrained, stable. When the current structure, whatever it is, just can't handle that tension anymore.
It has to change.
It has to reorganize. It
Yeah.
moves to a higher, more stable, more coherent form. And importantly, this isn't random. It needs a very precise balance of three complementary principles.
All right, let's break those down. These are the three things needed for potential to actually become something stable, something real. First, you need energy.
Which the sources define pretty simply. It's the medium for motion, for possibility, for flow, just raw potential, really.
Got it. Energy. Then number two.
Structure. This is crucial. Structure provides the boundary, the coherence. It's what lets energy stabilize, stick around and even accumulate information. Think of like the container or the rules of the game.
Okay, energy and structure. And the third piece is direction.
Right. Direction is what stops things from just getting stuck. It's the force pushing towards change, towards novelty, towards innovation. It ensures things keep transforming.
So energy, structure, direction.
And the absolute core insight here, and they argue this applies everywhere from like atoms forming to nations thriving, is that complexity only increases when structure and direction are kept in equilibrium, a perfect balance.
What happens if that balance is off? Like if structure takes over?
Rigidity, stasis. The system becomes too inflexible, too locked down. It can't adapt or innovate. Think of like a super bureaucratic government that just grinds to a halt. Or maybe a company culture that shuts down any new ideas.
Okay, too much structure is bad. What about too much direction?
Chaos. Coherence just dissolves. You lose stability. Things fall apart. Imagine a society or a marketplace with literally no rules, no agreements, no boundaries. It just breaks down into instability.
So the sweet spot is right in the middle.
Exactly. According to this law, the universe is always striving for that balance. Maximum flexibility held within maximum boundary. You need both freedom and constraint, perfectly balanced.
Which brings us to maybe the most radical part of this framework, how it redefines awareness. We need to sort of set aside our usual ideas of consciousness, thoughts, feelings.
Human stuff.
Yeah, and replace it with this term, structural responsiveness. Can you unpack that? Because this seems like the bridge connecting physics to, well, even things like morality.
Absolutely.
Yeah.
Structural responsiveness is basically the ability of any system, and this could be an atom, a cell, a person, a society, to detect relation, to pick up information from its environment.
Okay.
And then, crucially, to internally reorganize itself because of that information. And the result of that reorganization is always a move towards greater order, greater coherence within that system. It's like a feedback loop, but it's structural.
That sounds very mechanical,
Yeah.
almost cold. Are the sources saying things like conscience or social bonds are just like efficient feedback loops, not something deeper?
They'd argue the feelings, the moral sense we associate with conscience, those are emergent effects of this fundamental structural function. The ultimate goal, structurally speaking, is always to minimize disorder and maximize stability given the system's limits.
Hmm.
We can actually trace this across the different layers of complexity, this cascade. Let's start at our level society.
Huh.
Here, structural responsiveness shows up as conscience.
Right, you can see that almost mechanical response in social situations.
Yes, the source gives this really vivid example. A young child playing alone, totally spontaneous painting walls, cutting her own hair, just unrestrained. Her behavior is kind of unpredictable.
Yep, sounds familiar.
But then the moment she realizes someone else is watching, is observing her internal state shifts. It reorganizes to align with the social norms she's detected. Her behavior suddenly becomes careful, deliberate.
Coherent with expectations.
Exactly. Observation literally forces a structural realignment within her.
Okay, that's the social layer. Let's go down one level. Biology. Here, structural responsiveness looks like signaling.
Precisely. Think about a single organism could be anything, an ant, a fish. On its own, its behavior might seem random, hard to predict.
Right.
But then it detects a signal, maybe a pheromone trail left by another ant, or an electrical pulse from a predator, or even just a change in light. Its internal systems reorganize in response to that signal.
And that leads to
Highly coordinated group behavior. Think of a swarm of bees, or that ant colony perfectly aligning. Individual randomness gives way to collective coherence, purely because they registered a relationship, a signal.
Okay, down again. Chemistry. Now we're talking bonding. Atoms just floating around.
Interact pretty irregularly, yeah.
Yeah.
But once they get close enough proximity matters, they can register each other's electromagnetic fields. That's the signal.
And that triggers the reorganization.
Yes, charge shifts around inside their structure.
Yeah.
This internal adjustment actually lowers the overall potential energy of the combined system. Now the result, the chemical bond. That's the first really persistent, stable form of organized relation. Structure gains a kind of memory, continuity.
Wow. Okay, next stop. Physics. Responsiveness here is just interaction.
Fundamentally, yes. Isolated particles, they behave probabilistically, their paths are uncertain, but when they interact through attraction, repulsion, the basic forces that relational signal triggers an internal reorganization
Which locks them into patterns.
to stable, predictable relationships. This is where the laws of motion actually emerge from. Randomness gets narrowed down into the consistency needed for physical laws.
Okay, and the final layer, the boundary between raw energy and structured matter. The sources call it nixia.
Yes, nixia. Think of it as this dynamic transitional field. And here, structural responsiveness is differentiation.
Differentiation.
So when an interaction happens within this Nixian field, that continuous wave-like sea of possibility reorganizes itself internally, kind of condenses, and you get localized quantidiscrete packets of structure.
So the same pattern repeats everywhere.
Exactly the same process, just different manifestations. Detect relation, adjust internal structure, resolve disorder into a more stable form. That's why they say observation is participation. It's the trigger for that structural phase change.
Okay, now we have this mechanism, structural responsiveness. Let's test it against the big one, the double slit experiment. This is probably the most famous, maybe the weirdest experiment in physics.
Absolutely. For anyone needing a quick refresher, you basically fire particles, electrons, photons, whatever, at a barrier that has two narrow slits cut into it.
And behind the barrier, there's a screen to see where they land.
Right. And the results are just bizarre.
Hmm.
If you don't try to figure out which slit each particle goes through, you just let them fly. They act like waves.
Meaning they seem to go through both slits at the same time?
Effectively, yes. And they create an interference pattern on the screen behind those characteristic bright and dark bands you get when waves overlap. It's like pure distributed possibility.
And this is the kicker, the second you put a detector at the slits to see which path the particle actually took.
The moment you observe it.
The wave behavior vanishes. Poof. The interference pattern disappears. The particle suddenly acts like a tiny bullet, picking one slit or the other, not both.
And that's the paradox. How can simply looking change the physical reality of what happened? It's the infamous collapse of the wave function.
So how does the ULIC framework handle this, using nixia?
Precisely. It argues that the particle, before it's measured, isn't quite fully physical yet. It exists within nixia in that dynamic equilibrium state we talked about, balance between structure and direction. It's potential energy.
Okay, so before measurement, direction is dominant. Openness, possibility, hence the wave-like state spreading out.
Exactly. It haven't been forced to commit to one specific configuration yet.
Then the measurement happens, the
Mhm.
detector. What is that, structurally speaking?
The detector isn't just passively looking, it's causing a structural coupling. It's a physical interaction, and critically, it's a structure capable of retaining information about the interaction.
Ah, so the detector provides the structure part of the equation.
Yes. Structure asserts itself through the detector. This coupling stabilizes one specific configuration out of all the possibilities within that potential field. It resolves that temporary equilibrium in Nixia. That's the moment of collapsed potential energy transitions into measurable fixed form. It's decoherence, viewed through this structural lens.
So observation isn't spooky action, it's structural coupling, resolving potential into actuality.
That's the argument. It takes the mystery out and replaces it with a consistent mechanism.
Which implies that the act of something forming, whether it's a particle becoming definite or maybe something larger, follows a consistent logic. The sources boil this down to a kind of three-beat sequence.
Yeah, it's a useful way to see the pattern. First beat, open. That's the state of distributed potential, many paths coexisting. The wave,
Second beat.
hold. Constraints start shaping that potential. This is where you see things like interference patterns, accumulating possibilities, being guided, but not yet fixed.
And the third beat, fix.
Fix. The structural coupling happens, the measurement, the interaction. One configuration stabilizes, becomes locked in, recordable. Relation becomes boundary, potential becomes form. Open, hold, fix.
Okay, now for the big leap. We promise to connect this quantum stuff back to the human world. The source material insists that observation in a physics lab and, say, awareness or conscience in the human mind are just two different flavors of the same underlying structural process.
It's the crux of the whole unified claim. If these laws defining stability at the quantum level are truly universal,
Then they must also define stability at the social level.
right, and look at successful human systems, thriving businesses, stable governments, functional cities, the argument is they must be maintaining that same delicate equilibrium between structure and direction.
So direction is like freedom, innovation, new ideas, market dynamics.
Exactly. The openness, the exploratory drive. And structure is the container.
Mhm.
The shared laws, the trusted institutions, the verified standards and agreements, the boundaries that provide coherence and predictability.
So when we see persistent problems like widespread poverty or societies collapsing, the ULIC framework would say that's a structural failure, an imbalance.
That's exactly how it's framed. It's not fundamentally different from a quantum system collapsing into chaos because direction ran wild, or getting stuck in stasis because structure became too rigid.
So if a society has too much structure,
You get those rigid bureaucratic systems. Maybe they provide a kind of surface stability, but they crush innovation, they can't adapt, and they often create poverty through sheer stagnation. Direction gets choked off.
and we definitely see societies where direction seems dominant, where things feel chaotic.
Yeah, that's the other failure mode. Too much freedom without enough coherent structure leads to instability, conflict, a breakdown of trust. Boundaries are weak or ignored. The sources argue that our ongoing failure to translate all our scientific knowledge into widespread, stable prosperity is proof that we haven't mastered the structural mechanics of our own layer of complexity yet.
So poverty isn't seen as just like a lack of resources.
No, fundamentally, it's presented as a structural problem, an inability to achieve and maintain that crucial balance.
The goal for a sustainable civilization, then, using this model, is to design institutions, laws, markets, social norms that act like those effective structural couplings in physics. Structures that maintain openness but also enforce coherence.
You got it. Institutions that balance freedom and order. Prosperity, in this view, isn't some clever political invention. It's the natural outcome, the expression of a complex system that has successfully found its structural equilibrium.
It's like nature finding a stable form.
Precisely. And look at science itself. It perfectly embodies this balance, doesn't it? Direction is the endless curiosity, the drive to explore the unknown.
And structure is the rigorous method, the peer review, the verification, the need for evidence.
Exactly. That balance is what allows knowledge to stabilize into something reliable, something we can build on. It turns speculation into truth.
So wrapping this deep dive up, the big takeaway seems to be that observation, whether by a scientist's detector or a person's awareness, isn't some weird exception to the rules of the universe. It's actually a fundamental expression of natural law. It's that structural threshold where energy, through relation, stabilizes into coherent form.
The laws governing an atom forming and a society cohering are, at their root, the same structural laws.
It suggests a deep unity.
It does. And it leads to a pretty profound conclusion the sources draw about how we should approach our biggest problems. Science advances through humility, right? Through the willingness to question everything, to revise our ideas when the evidence demands it, like physicists had to do with quantum mechanics.
We need that same humility for social problems.
That's the challenge posed. If the stability of an atom and the stability of a civilization really do follow the same deep logic, and if poverty, as they provocatively claim, isn't unavoidable fate, but the next frontier of science,
Then we have to ask a different kind of question.
we have to ask, what structural change is needed in our societies and our institutions to finally achieve that durable natural balance between freedom and order? That's the ultimate test, perhaps, of whether this universal law of increasing complexity truly holds up. It's something to really chew on.